it's a very broad topic, and well, it cannot be exhaustively presented here. So my main idea is to give you an overview about the work I'm in the last years, and what some of my colleagues are also doing about working on multimodality. So and I go here. This position. Okay. Oh, okay. So the first two sections are just definition. I think most of the stuff you already know. Then I come to some philosophical perspectives, giving you an idea about the arguments, both pro and against multimodality. I come then to multimodal reasoning as a specific topic in natural intelligence, and then I give you another philosophical perspective, which is not so much about the arguments, but more about the history. So whether philosophers were working on the topic of multimodality from the modern perspective before. And then I came to a very short outlook about multimodal reasoning in artificial intelligence and a conclusion. So let's start. What is multimodality? And well, what I understand about modality is mainly receiving or expressing a different kind of data. Here can be input or can be output. And most people normally distinguish between multimodality, multisensory, and of course multimedia. I will avoid that, keeping things simple here, mainly only speaking about different modality and modality types that can be, for the sensory channel, it can be here visual, tactile, and acoustic, or if it's about the media or communication tool, it's about diagram, speech, text, and so on. Well, what is more important is this three distinction you have here about unimodal, multimodal, and cross-modal. Means that unimodal is one modality type, for example, speech and diagrams, where one modality type is going to the same one. Input and output is from the same type. Multimodal is a combination of these modality types, can be, for example, speech and gestures, which are combined, and there are in the literature a lot of different distinction about how they are connected to each other. Or it can be also multiple modes which are involved, visual and tactile, for example. And the third one, that is a cross-modal, the notion of cross-modality, that means the change of the modality type. You maybe know that from different apps, like going from text to speech, or other way around. You have here, or from different modes, like acoustic to visual, from input to output. So there are a lot of fields of multimodality research that is not an exhaustive list you see here, and I'll just give you some ideas. For example, in animal communication, people are researching, for example, in primates, chimpanzees, how they communicate with each other, how gestural, verbal expression, facial expression are used. Well, in cognitive science, people examine how the brain processes different types of modalities going on, and we have a lot of areas in artificial intelligence or in computer science in general where multimodality is a big topic. I guess, for example, you know some of the programs which are working on the modern one, which are most famous, I think, that are multimodal large language models, for example, like Gemini or a modern version of ChatGPT, where you have different modality types coming together as an input or can be produced as an output here. And you normally have just, so the term sounds a little bit strange, multimodal language model here. So the language engine is normally a basic for that, and you have, for example, a visual encoder, and that is connected in some way with the connector, and so you get a different kind of input or output. Okay, there are also different types of communication. If you just look at human communication, you normally see that we have here visual, tactile, and acoustic modes are coming in. And if you have a look at the combination here, this Venn-type diagram on the right side, which you see here, you see there are different forms of connecting or non-connecting to each other. So the areas 5, 3, and 7 that are unimodal modes, for example, where you have only in area 5 only the visual modality type, or in area 7 only the acoustic type, and then you have a bimodal approach in area 6, for example, where 2 modality types are connected to each other. Or in area 1, you have a trimodal approach where all 3 kinds of communications are involved. Well, what we also did is we used an extended canon continuum. So this canon continuum is normally used only for gestures, to classify gestures here according to the complexity of information compressed in a signal and the degree of conventionalization you have here. And we enhance them with not only with gestures, but with also other modality types like diagrams, written text, sign languages, and so on, to classify that and give you just an overview about what these modality types are or how they are classified. And you see, for example, if you have something like here, like a beat gesture, it has a very low degree of conventionalization and it's not very much information which are compressed in the signals. You just use them, for example, in different types and just say, well, this, that, and that, for example, and you have that. Maybe we can have the question later on.
It's just a clarification question. What do you mean by conventionalization?
Well, yeah, I give you an example for if you have a look here at written text or sign languages, which has a very high form of complexity and conventionalization. You have, for example, you have grammar, or you have an alphabet, so to say. So that are the kind of conventionalization which are normally used. So it can be also come in a written text, can be symbols or formulas and so on. So that are all things we agree on when we use this kind of stuff. So it's not spontaneously given, it is only, well, yeah, it's a kind of things we learned from very early age, so to say. Yeah, one of the questions I will later come on is, for example, diagrams, which are classified here as a medium complexity and also normally seen as an intermediate degree of conventionalization, whether they are classified really in that sense. It is given here in this canon continuum. Okay, now come to another kind of definitions here about natural and artificial intelligence. That is not something new, just to remind you about what I think I'm working or what I'm speaking about. You see here, if we have again a look at this slide about the different fields of multimodal research, we see, for example, that the first 2 areas are mainly connected to natural intelligence. So, for example, animal communication is, of course, not about artificial intelligence. It's about primates or non-human animals in general. Education is also human-centered. And then we have other disciplines like linguistic, cognitive science, which were basically or historically seen, they were based or centered on humans, but they contribute more and more to artificial intelligence. And of course, we have these 3 kind of areas, which I just took here as an example in order to give an expression, which are the disciplines on multimodal research, which are normally connected to artificial intelligence. Well, what means here natural and artificial intelligence? Also, that is not something what is new. Natural intelligence here means mainly the cognitive capacities of humans or animals, including perception, learning, reasoning, adaptation, etc., etc. And I will mainly concentrate in the next slide about reasoning. What is typical is that we are biological entities, and therefore we have this evolutionary perspective which is going on here, and that provides us with a lot of flexibility, intuition, generalization, and so on. Whereas as a contrast to that, artificial intelligence is not about biological entities, but more about computational systems, which normally are not involved in an evolutionary processes. There are, of course, some areas like evolutionary computing and so on, where these principles are adopted, but that is not typical for this kind of system. That are more systems which are created by algorithm and data processing here, and they simulate cognitive functions of human and will speak here mainly about weak or narrow AI. That means that are machines for solving different kinds of tasks here. Okay, having a look at reasoning in natural and artificial intelligence, you will see that reasoning is, there's a big debate, especially about how animals reason. For example, there are, just to give you some catchwords here, reasoning without logic and also proto-logic are typical debates you find in areas like animal minds or animal reasoning. Here means the question, can animals have similar, or we can see that they behave in a similar way and inferring some kind of data, but of course they are different in that way that they don't have explicit theory like humans have on deductive, inductive, abductive inferences and so on. And therefore normally people distinguish here between a dual process theory having two systems. System one is more intuitive, system two is the reflective one, where we have different kinds of theories like we are using when we normally speak about logic is a kind of discipline here. And one of the questions which is a longer debate in the last years is the question of how can animals behave in this logical sense or reason in some ways without having a theory of logic as we normally have here. So reasoning in artificial intelligence started with a logic-based approach. You have a formal system here, including explicit rules, for example, an if-then rule here. These are systems which are interpretable. You can trust them. You know that they work well. We can prove their correctness, and therefore we trust all these systems here, but they have a problem normally with unstructured data. So people started as sometimes with working on machine learning, where you have some algorithms which work very well with unstructured data, but we have this problem, this black box problem. We don't know what actually happened here, and therefore they are not well explainable in that sense. And where I'm mainly interested in is a hybrid AI approach, where you have on the one hand the logic-based stuff, and on the other hand you have the machine learning idea, and that are systems which are trustworthy and adaptive in the same way. That is also a slide I would say we can discuss for a very long time, but just give you an idea what is the goal of artificial intelligence, or what I would understand as a goal of that. You can say, well, machines normally are, the artificial intelligence is normally a tool which helps us, which simulates, imitates, and mimics natural intelligence in some way, but there are of course problems. For example, we have differences like AI normally don't have the access to the system one, so there is not a complete embodied AI approach, and well, it is not possible in the moment to predict whether AI will ever have something like feelings or emotions like we have, and therefore there are a lot of differences we see in the moment, but from that there results a normative approach. And that means mainly that AI should support us in some way, and if it should support us, we normally want that these systems do not reason in a very different way or behave in a very different way. So therefore, we normally work on AI in the sense that we say, well, these tools should help us, and therefore they should imitate what we are also doing here. That's the same here. I just give you a quote. That is the same as some authors claim here about reasoning in AI. So we want to have AI systems which reason or are doing logic here in the human style way, human style fashion. What is going on? Okay, that were just the definitions. I now come to the first kinds of philosophical perspectives, and one of the main questions I was asked for me for some longer time is the question: why are some philosophers interested in multimodality, others are not? And I would distinguish between two main groups of philosophers or schools. The first one I would call normally rationalists, and they argue that intelligence, reasoning, or rationality is given. We also have two different approaches here. The first one are the internalists. They say, for example, well, intelligence or rationality is given by nature and innate in the mind. And the other groups say, well, we have, for example, a supernatural being, and that's made with this logic, all the things we see in the world and also in our mind. And that are normally a group of philosophers who argue for a kind of logical monism. So they say there's only one true logic we have here, and we should concentrate on finding out how this one true logic looked like. The other group of people I normally subsume under the notion of representationalists, that can be typical empiricists, that can be transcendental philosophers, phenomenologists, pragmatists, for example. They normally argue that intelligence, rationality is acquired in some way. We can also distinguish them into groups, the internalists and the externalists. So the internalists acquired or say that rationality is acquired privately through the senses, and the externalists, they say, well, it's acquired through some social interaction, and they are normally agree on logical pluralism, so they don't search intensively for this one true logic, but say, well, we are using different kinds of logic depending on the situation we are in or depending on the interaction we are involved. So I just give you a few ideas about, I try to find some modern position about that rational internalism here. For example, there were authors who say that logic is something like a biological class, similar like a kind of virus which comes in the mind of humans, and then humans interact like biological systems, that the logic also developed in different kinds of logics we have, but there is one string of a true logic which is behind all that kind of different mutations we have there of logic, so to say. Well, rational externalists, for example, they, as I said, they start most often from a supernatural being, saying, well, that made this world and everything in it, like, with an own logic here. And therefore, if we just have a look at the world in our minds, then we can, by analogical reasoning, we can figure out how this logic is. So we have there a connection, so to say, or an analogical inference to this one source of rationality which is given. Now we come to the other side, the representationalist, and they, for example, it's more different to find this group of philosophers. They argue, for example, that we acquire our intellect, our rationality during our life, normally in our childhood, and that in interaction with our environment, mainly with our physical environment, that we figure out how all the stuff is going we are working with. And the last group here, that is an idea which I'm more involved in, so to say, that has a perspective here on external representationalist. Well, that's the idea also, like the first group of people we have, where we have a development in history, but that development goes very long back in time. So Aristotle was, for example, not the founder of logic, but the founder of a system 2 kind of logic, where we have the first one who made a textbook on that, a whole theory, but normally logic is something, or rationality is something which comes up for a very long time when people are in a social interaction with each other. And you can see that, for example, in economics, or you see that from legal processes. Yeah, that says that logic and reasoning is something like a social practice which we are mainly involved in, and only later comes more and more comes the different kinds of logic. Yeah, what does it has to do with our topic? So my main hypothesis, I would say, and I try to figure that out also in perspectives, in the philosophical perspectives too, which I later present to you, is that the people, the rationalists, which are in favor of logical monism, normally also are involved of favoring a unimodal approach, saying that there is only one modality type which is the best one to reason with, whereas the representationalists normally have different modality types, and therefore they are not only connected to logical pluralism, but also to multimodality. And I give you later in that section some historical ideas about how that these two groups were in interaction with each other. Okay, before that I come to multimodal reasoning in natural intelligence, giving you more a modern perspective here. And what psychologists from different areas, for example, in psychology, in typical psychology, in education, math education, in physics, and in logic, found out the last especially 30 years, is that a multimodal approach is normally more successful for natural beings than a unimodal approach. There were a lot of tests here about, for example, a bimodal approach of text and diagrams in physics, gestures and speech in mathematics, and also text and diagrams in logic. And they normally found out that people are more successful on the test when they use a bimodal approach than a unimodal approach. So the question now comes up, why are we not all the time doing this multimodal approach, but normally worked on a unimodal approach, so having only one kind of reasoning system like a text-based approach. And for example, there are a lot of studies for the 20th century about using a multimodal approach in mathematics. And even people in the 20th century, in about 1920, 1930, had the impression that they were in a kind of period in history where they focused only on a unimodal approach. They called that, or gave that the name, a crisis in intuition, because they said, well, the system one we are normally connected with, that with all the other modality types, that seems to decline, and only we are focusing on system two with one modality type here given in. So for example, mathematics was mainly based in the 19th century, and also logic with diagrams and with text, and then it declined. There are also, thanks to some colleagues from Denmark, empirical data which proves that that is true, that you have, especially at the beginning of the 20th century, that you normally have a unimodal approach in logic. So all the other kinds of modality types declined for mathematics, and you can see the same result in physics and also in logic. Yeah, so well, but on the other hand, we can say we were successful during that time, but to some cost. So we lost a lot of ideas about multimodality, which especially the representationalists were working on up to the 19th century. Then came at the end, you saw that it increases at the end of the 20th century. Then you saw there are some, well, some call it the paradigmatic turns we have here. There were forerunners for that. For example, you have in theoretical physics, you have the Feynman diagram, or in technical engineering, you have Akana and Weizsäcker. Category theory is an example for proving that there are also exceptions for what I describe as in intuition, but only with the 1990s, technical innovation started, which helped to increase this multimodal approach, which is now more and more in the focus of many research disciplines. So, for example, we have the audio and video recording, which helps us to make analysis about different types of communication, for example. And we have graphical user interfaces with personal computer, which helps us to produce a lot of multimedia content, and multimodality content. Well, and there were some, so to say, some paradigmatic approaches like in linguistics, where people started then working with text and gestures. In math education with speech and gestures, and psychology, we have this so-called McGurk effect. You maybe have heard of that for having hearing and vision combined here as a bimodal approach, which started then to grow more and more. And in logic, people started working with text and diagrams. For example, what I presented first is the approach by Sunju Shin. And what she made was first a cross-modal approach. Yeah? That means she had symbolic or text-based logic as a model, as a template, and transferred it to diagrams as another kind of modality type. And the idea was, or the question was, can we do the same stuff in diagrams, for example, of what we did before in text-based logic? And yeah, they said, well, we can distinguish diagrams not only, or not using diagrams only as a heuristic tool, for example, as something coming up from system 1 and supporting us in system 2, but we can make really a reflective kind of theory in logic with diagrams. She distinguished between syntax and semantics. In syntax, you have at first the definition of what is a diagrammatic object, then what are well-formed diagrams, and then most important transformation rules for manipulating one diagram so that you have a diagram as a result, which is, so to say, the end of a series of manipulated diagrams. You have like a kind of deduction, which is going here. Yeah, and semantics, as you see here, set assignment, satisfaction relation, and so on. And that helps, of course, to make the same proofs which are before used in symbolic logic in order to show that this kind of diagrammatic systems were sound and complete. Just to give you an idea how today this kind of diagram looks like. On the left side, you see a Venn-based approach. I before used a Venn diagram on one of the slides. You see here, for example, systems on intuitionistic diagrams and non-monotonic diagrams. One of my colleagues in Münster is working on that. Lower one is about belief revision, for example. They were done by Ritu Bhattacharjee. And on the right side, you see here Euler diagrams. The first one is with using existential import, a sequent Euler calculus. And the one at the bottom is an approach I'm working on since some time. We're having diagrams without any existential import here going on. And that was a kind of working again in a unimodal approach. So at first we had this paradigmatic turn where people tried to import the stuff from text-based logic to diagrammatic logic. And then other research groups started working only on diagrams. And what then came up is working with both. So now in the moment, a lot of people started having multimodal approaches. On the left side, you see, for example, diagrams and concepts. So M-text here, that is for ontology engineering here. And on the right side, you see here a typical prover, logical prover, which has an output not only on a symbolic logic, but also on diagrams. And you can choose which one you use, or you can also combine them in some ways. Okay, you may say that are all new ideas, but I would say a lot of philosophers, especially the representationalists, did that before the 20th century. And I'll give you just some example. One of the first one You might see here that is an approach by from the 16th century. That is an author who used also this kind of logic diagrams, and he took from system one some kinds of objects and seen there the same kind of relations here for logical diagrams as we normally perceive in the system one. So taking the objects, the geometrical logical forms here to a kind of theory. But there were much more. For example, in the 16th century, you find a lot of approaches here using diagrams and gestures. Yeah, and that was very common up to the 17th, 18th century because people don't had books or had the possibility of drawing diagrams or working with text, and therefore most of them normally took a kind of logical reasoning, similar as you are counting with the fingers, so to say, in logic. Then you see here from the 17th century, Erhard Weigel was the teacher of Leibniz. He used a text-based approach and used the alphabet here in the form of diagrams. And on the right side, that is not a representationalist, that is normally someone who is connected more to the rationalist, but I took him here because he was a professor in Tübingen, that is Gottfried Bouquet. And he also argued that you can have the same results, whether you use diagrams or symbolic logic, it doesn't matter, but he normally preferred symbolic logic because it was shorter. Yeah. That was one of the main arguments he used here. And you see on this diagram, Bouquet used a combination of both diagrams and symbols. Well, and as I said, what is most important here for transferring logic diagrams or using them not only as a heuristic tool, but also transferring them to a reflective system of logic, that is using rules. Rules, transformation rules for manipulating diagrams. And normally one of the first who said we did that is Peirce. You see here, for example, the manuscripts and some of the collected papers in which Peirce used different kinds of rules for an Euler diagram system here, and he showed that you can go from the left diagram to the right diagram by using one of these two rules. That was the inspiration for the people who worked up to the 1990s on the diagrams, on logic diagrams. But the approach is much older. You can see that, for example, in Kant, he also tried to do the same one. That is from one of Kant logic manuscripts here. And he used, it's difficult to read, I'll just give you an idea. He used here the edges of this kind of graph in order to show the premises and the conclusion here. And he manipulated the diagrams in order to go from one diagram to the next diagram. And you may ask, how can you do that? You just draw a different kind of diagrams. In some cases, you also give here rules, like you see here, metathesis premissarum. So you can take the premise here between SMM and M and P, and you just turn it around, as you can in some cases turn around the premises in a text-based inference. And then you came at least to the kind of diagram. So that are all old ideas, so to say, but they were reinvented. What are doing in the moment, that is the last outlook, so to say, multimodal reasoning in artificial intelligence. Well, what is the main focus, I would say, is most research groups focus on syllogism. They are seen in the moment as simple case studies for reasoning in both natural and artificial intelligence. Well, in the field of animal minds, some research groups say, well, animals also reason, for example, in a syllogistic way, but with the help, they don't have a language, therefore they are using geometrical shapes here in that form, and therefore that is close to spatial or diagrammatic cognition. Well, the psychologists normally say, well, we humans use syllogism better and faster with a multimodal approach. I already spoke about that, and we are doing that frequently. There are some tests which say that we are normally behave or infer with some sorts of syllogism up to 30 times a day. And we are also applying that in different fields, for example, in legal reasoning, using that again. But the logic-based AI that is typical can solve a syllogism test to 100%. But you have to transfer a normal language syllogism to a unimodality. Normally it is symbolic reasoning, so text-based logic. But the problem is neural network cannot do that. So that was something which came up for a few years. You can put in as much data as you want. It failed, yeah, to some percent. But then that is, so to say, a current trend. If there are multimodal architectures, so if you can input the diagrams directly without converting them to a unimodal approach, then it decreases to almost 100%, and therefore there are some multimodal approach in machine learning, which you see here with different research groups are working on. And the result I learned a few weeks ago from some Japanese colleagues, they say if you're using, for example, a large language model and you put in here as a prompt, text and diagram, that normally works much better with this multimodal approach than you are only using a unimodal approach. Okay, let's come to a conclusion. Just some ideas about what I spoke here. Multimodality, in particular, multimodal reasoning is typical for natural intelligence. We are most often working with only one modality type. So the history of philosophy shows that there are numerous multimodal approaches, but they were neglected to certain periods in the history of sciences, not only in logic, but also in physics and in mathematics. Then they have to be reinvented because they were forgotten in our collective memory. So even the philosophers normally don't know about the multimodal approaches a lot of philosophers were involved in. But in the moment we see this trend in working not only with one modality type, but with more modality types. We can say we have a normative approach here. AI should simulate or imitate how we are reasoning, and if that is the case, it is the most successful way we see in the moment of having a successful unimodal approach, applying that to cross-modality approach, so taking, for example, text to diagrams or diagrams to gestures, for example, and then working in that unimodal field again and again. As a case study, I showed you here the text-based reasoning and the diagrammatic visual reasoning. But of course, there are other diagram types like haptic diagrams or acoustic diagrams. And what also is missing here, what we worked on the last 2 years especially, are logic gestures. So using again your fingers or your hand movement with the body in representing logical systems. And we can say, well, that is my, so to say, my normative statement for that is only a wide-ranging foundational research on unimodal and cross-modal approaches makes it possible to put all these pieces of the puzzle of multimodality together. Okay, that's it. Thank you for your attention, and thanks a lot for the support of the colleagues.